Hey guys, welcome back to Computational Biology. In this lecture, we're going to be working with sequence annotation from the Biopython suite of tools. So let's go ahead, get right into it. All right, if you're doing this on Praxis, you want to save your new notebook. I'm going to save mine as seq annotation. All right. Okay, so this is for specifically if you're working with a FASTA file, generally you don't have to worry about this stuff, but if you're doing things with GenBank or EMBL files, then this is a very important section to work with. So I'm going to start with from bioseq record, import seq record. All right. I'm going to do help seq record. Recrod. Okay, so as you can see here, this is how you pull up the help file. Lots of information here on how to use this, right? So you'll typically use bioseq.io to read and sequences from files as seq record objects. You can create your own seq records. This just gives you all the information on how to do a lot of this stuff. So that's available. I'm actually going to delete this cell because it's going to take up so much space, but I just want to show that that is available as well. Okay, so to create a seq record, you just need a seq object, right? So from bioseq import seq. You may have this already open or loaded, but if not, load it. We're going to say simple seq equals seq GATC. All right, so that's our simple sequence. And we have seq record started. So simple seq R for record is seq record simple seq. Recrod, man. There we go, record. Okay. So now if we do simple seq R, we get the seq record, right? So we have the unknown name, ID, description, and everything. We've created a record, but we haven't provided it any information yet. So we could also pass the ID to it. So we could do simple seq R and then .id, and we'll say this is AC12345. And we can pass it a description. Simple seq R dot description, and we'll say made up sequence for the VDB computational biology class. And now if we print it, or you just call it, actually let's just print simple seq R description. So we can print just the description. You can see that that is now stored in there. But if I call, and I can call something like simple seq r.seq, which is the actual sequence, it should give me my sequence, which is great. And then if I print out simple seek r, just everything, you can see now we have ID. We didn't give it a name. We got description, and we gave it the sequence. Cool. So this gives us a way to store sequences with annotation, right? So you don't just have a bunch of letters. You're like, where does this come from, or what is this all about? All right, let me see where. Make sure I didn't lose my spot. Let's do. So usually, all right, we'll skip that part. This is a good way. So having your ID and stuff is very important if you want your to write your seek record to a file. So that's kind of why we would use it. So let's do simple seek r annotations. We'll say evidence equals none. This is just an example. So what happens when we do this? And now let's print it. Simple seek r dot annotations. So you can also store things like that. So if we look at simple seek r, you can see it's stored in your simple seek r, but it's not shown when you look at simple seek r. So it's kind of like hidden in the back end, additional data. So you'd have to print it just like this. What else can we do? You can also do per letter annotations, kind of like scores for sequencing. So let's do simple seek r letter annotations. Fred quality, so this is exactly like for sequencing. So it gives scores to how confident the machine or the algorithm is that each base that it called when it did the sequencing is actually the base that it thinks it is. So we'll say 40, 38, 30. And now if we print simple seek r letter annotations, okay, so now we're going to actually use a real FASTA file. So I'm going to paste this in here, and you might want to pause it here to download. I'll try to remember to put the link in the description of the video, but sometimes I forget. But we're going to use this from GitHub, and I'm going to put this here so it doesn't, so it can remain in my code, and I don't have to worry about it messing up my code. All right, so you should have a FASTA file that looks like this. As you can see, this is a FASTA file because it starts with the greater than symbol, and it has a bunch of annotation up here, and then just the nucleotide sequence. So what we want to do is we're going to save as, and we're going to save this as nc_005816.fna, and then I'm going to upload it from my computer here. There it is. Okay. So now I'm going to do from bio import seek io, and record equals seek io dot read, and I'm going to say the name of my thing, nc 05816.fna, and then I'm going to tell it what kind of file it is. I'm going to say it's a FASTA file. What did I? Oh, I have to put quotations around it. That it's a FASTA file. Maybe I should not put a plus in the middle of it, huh? Why are my numbers way off? NC. Maybe my fingers weren't on the right keys here. 005816. There we go. NC 005816.fna. It's right here. Oh, it says .txt. There we go. Okay. All right. So now if we type in record, because that's what we saved it as, you can see that we have this record that has this sequence, and it's put in these annotations for us. Instead of us filling them in, we have a name, we have a description, we have whether it's a complete sequence or not, etc. in there. So we can look at this individually. So we can do record.seek and just get the recrod. Curse you, recrod. We get the sequence. We can individually pull the ID. We can individually do the description. So we get the actual organism. So just like before, we can pull out all these different things. Now, let's see. So it is important to also know that you can only get the information that is provided in a FASTA file, right? So record.dbxrefs, record. See, that's empty, so you can do record annotations that we did before. That is empty, and so depending on what type of stuff, record features, depending on what type of file you import. So if you import, something from Emble or something like that, it may populate differently because it might have that information. We just don't have that information in this. You can see there's no annotation spot or provided in this type of file. Okay, so let's keep on keeping on here. And the reason I can do this is because that package that that we used to import the record, the FASTA package, or FASTA, let's see what it's called, seekio.read, it knows the way that NCBI FASTA files are set up. There's a convention that they have to be set up a certain way. And so since it knows where to put things based on that, and so additional information like annotations aren't in this conventional format that NCBI has. That's how it works, I guess, based on all FASTA files should be formatted the same. They do a good job of curating to make sure. Okay, so we'll stop here, and then we'll, in the next one, start working with some other file types. So that's it for the beginning of the sequence annotations. It's really nice for being able to keep track of your sequences, know what sequences are, what the descriptions are, and things like that. You can get even more detailed. We will with some emblem or GenBank files and things like that, non-FASTA files that provide more information. So thanks for watching. If you're on YouTube, please hit like, please hit subscribe, and I will catch you in the next one.